we're going to find that in calculus, when we're working with polar curves, it's not only going to be useful to be able to look at an equation and know what the shape is, but also how the graph is created. In other words, as theta gets bigger and bigger and bigger, what are the theta values needed to trace the graph exactly once? Where are we on the curve when theta equals different values? These are going to be very useful things. So you may recall, yeah, r equals cosine 6 cosine theta is a circle whose diameter is 6, goes through the pole and goes off to the right. Yeah, okay, sure, that's true. But let's more importantly remember how the graph is created. So you don't have to do this every single time, but in the back of your head at the very least, think about what's happening with your r values as theta gets bigger and bigger and bigger. So I'll start with 0 and go up to pi over 2, and then go up to pi, and then go up to 3 pi over 2, and then go up to 2 pi. And you might just start with those convenient values just to kind of see what's going on. 6 cosine of 0 is 6. 6 cosine of pi over 2 is 0. All right, let's pause there for a moment and think about what that means. R starts at 6 when theta equals 0, and then as theta goes around the circle from 0 up to, or around to pi over 2, our r value decreases down to 0. Okay? And then we go through quadrant 2 angles, and quadrant 2 angles are going to give us a negative cosine all the way down to negative 6. So, going in the pi direction, we would go to positive 6 right here, but negative 6 is going to be in the opposite direction. So we're actually going to go back to where we started. So all of these angles that are going through quadrant 2, which are going to be, pointing off in the upper left-hand quadrant here, they're all going to have r values that are negative. So we're actually not going to go into quadrant 2 at all. We're going to go into quadrant 4. So quadrant 2 with negative r values means quadrant 4. So that means that we're going to start off with r value of 6, and it's going to get smaller and smaller and smaller. Notice that the r value is getting smaller because we're getting closer to the pole. All right. And then the r value is going to continue to get smaller, but smaller in the negative direction. So its magnitude is getting bigger, right? So if we're at 0 and we're getting smaller, we're getting farther away from 0, so we're going to spiral back out. And that's going to be one full cycle here. So we don't really need to go to 3 pi over 2 and then back to 2 pi. That's unneeded. The circle is traced once over the interval 0 to pi. Okay. And again, that's going to be a useful thing to know when we're dealing with the calculus side of things. All right, so let's try another one. R equals 3. Well, that's going to be, it doesn't matter what theta is, r equals 3. So, for example, r could equal 0. Theta could equal 0. Theta could equal pi over 6, pi over 12, pi over 6, pi over 4, pi over 3, 5 pi over 12, pi over 2. You see what's happening. We're going to get a circle. Interestingly, this is exactly the same size circle that we got on the last problem. Radius of 3 and diameter of 6. Eek. All right, good enough. But it should be clear that if we stopped at pi for theta, we would only get half the circle. This is being created in a different sort of way. So instead of having a circle traced over 0 to pi, we have to go all the way to 2 pi. So in this one, the circle is traced once over the interval 0 to 2 pi. Okay? And you can make a t-chart for that, but r is just going to be 3 no matter what I pick for theta. All right, so very different sort of creation for the same shape graph. All right, cool. This one's a little different. This one's a constant theta value, so there's only one theta value allowed, and that's pi over 12. This is like your vertical lines in the rectangular world, right? X equals a number is a vertical line. Theta equals a number is not a vertical line, but it is a line. It's a radial line. In other words, it's going to be a radius is going to come through the pole. And so pi over 12 is this line right here. And then we can have negative r values, so we'll go over this way as well. So that goes on forever in both directions. All right, so there is no range of theta values. Theta is just stuck at one particular value. All right, now we're getting into some more interesting graphs. You might recall that this is going to be some sort of limacon. So if you don't remember the main values, then do a quick chart. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Those are, generally speaking, good enough to get a decent graph. 2 minus 3 sine of 0 is 2. 2 minus 3 sine of pi over 2 is negative 1. 2 minus 3 sine of pi is 2. 2 minus sine 3 pi over 2 is 5. And then 2 minus sine 3 sine of 2 pi is 2. All right, so we go from 2 down to the minimum, back to 2, back up to the maximum, back down to 2. It's that whole oscillating idea of the wave. But we're taking that wave and we're kind of spinning it around the pole now. So we've got 2 and then negative 1, right? So we would have gone up to pi over 2, but the r value is negative. Now let's remember what this means, okay? The r value went from a positive to a negative. So since this is a continuous function, the intermediate value theorem tells us that for sure we've got to cross through 0. There is a value between 0 and pi over 2 for theta such that the r value is going to equal 0. We know that we have to go through 0 as we spiral in. We have to hit the pole as we spiral around to here. So even though our theta values are stuck in quadrant 1 for now, our curve goes into quadrant 3 because our r values are negative. And then we're going to spiral back out, mirror image, like that. Try to make it symmetrical. I didn't do a great job with that. And then we're going to go all the way down to 5, I believe it was. This is not the nicest limacon, but it'll have to do. Let's try that. And that might make it a little bit better. Yeah, that's halfway decent. Anyway, so that would be an inner loop limacon. We needed to go all the way from 0 to 2 pi for theta values in order to complete that loop. So theta goes from 0 to 2 pi to create the entire shape.